Hey, my name is Markku Rantanen from Arista Networks, Finland, and I will walk you through today with zero trust networking in campus networks. And first, a few words of me. I work here as a systems engineer, been in the company almost 9 years, and as a systems engineer in various of American companies, switch and routing vendors already over 30 years. So yeah, there was something called the internet that time already that back in history. So been there, seen a lot of things and touched many type of devices and networks. So and know a little bit of networking too. So let's kick started and start. Sorry, my slides are not moving. Let's start with the presentation. First few words of what Arista Networks is. Arista is a fairly young company, headquarters in Santa Clara in California, Sunnyvale, and so here this slide is described in the past 10 plus years, showing the success of Arista switching and routing solution. As you can see that the both the revenue and the market share and some key milestones within the course of the 10 plus years. It has been very successful time. You can see a small dip there in the year 2020. That was the COVID time, and when everybody had delivery problems of sourcing material and components, and that reduced, of course, the revenue a little bit for temporary reasons and times. And you can see since then it's been really rocketing. What Arista does is Ethernet switching and routing solutions for data center and campus networks. And you can see that, guess that basically after 2020, there has been a boom in the AI networking and high-speed networking. You can see 400 gig and 800 gig and soon to be 1.2 terabit Ethernet by ports. We have claimed market number one market share position in data center high-speed networking already end of 2023 and 24. And these revenue numbers here are from 24, since 25 numbers are not ready and not public yet, but the growth seems to be similar. So the growth has been healthy growth. The growth has been organic. So we have in-house developed everything that we sell. We have done a few acquisitions, but those are augmenting only our story, like adding more security in certain pieces of the solution. But the main solution, the software that we are selling, the switches and architecture are all in-house developed and not acquired any market share, so to say. So very successful time has been, and we look forward that still continue. So it's not only that what we say, it's also what the market analysts are saying as well. Here are three different segments of Gartner Magic Quadrant displays. So left part you can see data center networking, where we have not only the Gartner but also Forrester Group has stated us as being the best platforms for software-defined data center networking, and also a rapid growth into the enterprise campus market has been steadily growing towards the right corner. And since the publish of this, we have further introduced solutions like this zero trust networking that further help us to be in the right upper corner. And also we did an acquisition last summer concerning SD-WAN networks. That wasn't completely new area for us. We already had products into that area, but since the acquisition of VeloCloud, we have been positioned in the leaders quadrant in SD-WAN area as well. So where do we sell solutions? Basically everywhere. We could rule out firewalls. We don't really have a standalone firewall to be sold and that part, but anything that is part of the networking we have. So we have been strong and started our journey with the data centers. That is on the left side of the corner. We have developed together with our biggest customers the current spine and leaf architecture. 8 out of 9 biggest cloud titans are Arista customers, like Microsoft Azure, Google Cloud Platform, Facebook, Meta platforms, etc. Those are all based on Arista technology. Most of the AI fabrics as well. The AI is mentioned here in the lower right corner. So the AI market for both for the training and inference. Training is where you train the models for the AI. Inference is when you're using the AI, you're using the prompt and asking whatever questions from Chat GPT or Grok or similar. That is always using those AI fabrics. So those are the backend network behind the AI computer nodes. Then, of course, the campus, which is today's topic here, and campus is very strong area, heavy investment area for Arista, and that includes the same architecture, same technology that you use for data center networking, including all the EVPN and other technologies, and of course the zero trust. Secure networking, which is today's topic. In addition, we have all these internet peering and routing solutions, service provider solutions. Back in 8 years ago, we changed the market for the routing technology by introducing devices that were a fraction of price but still capable of doing internet scale routing. That changed the market as a disruptor completely. So what's all behind all this? It's the operating system. That is our foundation and crown jewel, EOS, Extensible Operating System. It is something that we have developed from the clean table. We are a fairly young company, as I mentioned in the first slide. This means that we don't have the legacy to carry on from the network from the early 2000s or even 90s. So of course the Ethernet packet is even older than that. That of course is carried over. But the technologies and services used in that time and the operating system at that time, they claim today that they have all these telemetry and other nice features, but those are bolt on, they are afterthought. All these current modern ways to build an operating system has been built into our software development since day one. And the result is very high quality software, low number of bugs, lowest number of CVE exploits in the amongst the other vendors, and Linux-based architecture, automation at every level, every device, every use case, and real-time state sharing, telemetry support for all devices and all software components. That is something that sets us different and makes it possible to have use the same software image for all types of and size of networks. This means that the software image is the actual same image in every network. We don't just call it the same name. It is the same physical binary image that you can copy from our download site and use it in the smallest device that we have or in the biggest device that you can imagine. It's always the same software. We are not really new to the campus network either, even though we started the process and journey with the data center networking and cloud networking. That is what we had pre-2018. That means that we had this universal cloud networking architecture that any size of a data center network or cloud network could use. We had best practice principles co-developed with the cloud titans, and they work, as everybody knows, how the spine and leaf architectures actually work with the small networks as well. So we are the pioneer in that area. And EOS and CloudVision are the single software and single management software for running these networks, and then programmability, for instance, in every area. And everything is based on open standards. We never do anything proprietary. With this information and this knowledge that we had from the data center and cloud networks, we have leveraged that and moved towards the enterprise and campus networking by using the same technology there. The networks are smaller, devices needed are smaller, and we have had heavy investment into a wide range of portfolio for helping customers to build campus networks. But that's not enough. So we have always started with security, embedded security, with our Wi-Fi solutions having web security embedded there in every device. And we already initially, when went into campus market as well, introduced NDR, network detection and remedy, embedded AI functionality both in the network configuration creation, any issues in a network troubleshooting, root cause analysis, and also AI helping threat detection. We have then added access control, network access control software and microsegmentation story, and together with access control, NDR type of network detection, threat detection, and microsegmentation, we can call it, together with a networking solution as a full-blown zero trust networking solution. So one word here from the data center to cloud and campus networks. From architecture perspective, no difference. Same hardware basically. The hardware is of course smaller and less throughput than what you have in a data center, and less scale as well. But it is the same family of products. It is running the same software. So that means that you have consistent and standard-based design options like layer 2 and layer 3 and VXLAN EVPN networks. And you have the same management and operation models and single architecture. You can use same architecture in any of these networks. And also all the tools, automation and analysis tools, security to embed anywhere in a network is much easier if you have common architecture to deploy it onto. So the device is what we have. This is not meant to be a product presentation in such. So it's just showing a glimpse that what we have for campus networking. We have a whole lot of more devices in the data center and routing environment, but this one is using here a core layer where we have a multiple different design and size options from smaller to medium and large size campus customers. Same in an access layer, both copper-based BoE and non-BoE and fiber options from low end to medium size, large and high scaling customers. Optional MACsec requirement as well for customers who needs those. BoE options from 30 to 60 to 90 watt options available as well. So the Wi-Fi solution, that was a ground changing and shaking solution when we introduced that, a completely controllerless Wi-Fi solution where the actual control of the Wi-Fi is implemented in the Wi-Fi access point itself. So that way it can scale as far as you can imagine. You can start with one, but you can end it in the same week with 1,500 or more. It doesn't matter. It scales very well. So that was something that changed the Wi-Fi portfolio option as well in the market. So zero trust networking is of course relying on a network, and since I already mentioned that we have common architecture between cloud, wide area network, data center, and campus networks, it is much easier to deploy any services if you have common architecture and common software there. You don't have to do security compliance many times per each architecture and each operating system. If you have common architecture and common deployment model, then you know that this network is always compliant. You fix it once, deploy it once, you operate it in the same way. And of course, the zero touch operations and cloud vision software is an example that because the underlying network is based on single architecture and software, you only need one management software. Embedded with zero trust components like the network identity. We have a product called Agony, Arista Guardian for Network Identity. Then we had network detection and response. And that is the NDR solution that can monitor and analyze the traffic and hunt for threats in your network. And that does it with AI help and does it automatically and autonomously. And then the segmentation and policy enforcement. That is the part for the network actually does. So this is the switches and routing solutions. They can actually do the policies at the micro perimeter level. Let's go forward and check a little bit more. So the network is the foundation. You need a network. We truly believe that the network is the place where you should do the zero trust networking. Uh, in addition to the end host that you have, you can have in your servers, in your application level, and you can have at your workstations, laptops, phones, for instance, you can have your security endpoint detection remedy software, but the traffic and the threat is actually traffic in the network too. So in addition to your endpoint protection, you need to have something that works at the network level and understands who they are talking to and what they are doing secretly in the network. That's why it is important to have access control. You need to identify the users, and the network is an enabler here because you, of course, you enable these at your switch level and your Wi-Fi access point level. And the segmentation, those are how you do the segments in a network. You basically do the VLANs and VRFs, which are routing domains in a network. But in order to do micro segmentation and how to do that, other than forcing all traffic going to a firewall, which would be a bottleneck. So in case to do it high scale manner, wire rate, network wide, then you can do it in a switches. Threat detection is also a network feature because a properly implemented NDR solution can see all the packets in a network. And there you need help from the switches, either implementing the NDR directly into the switch or copying the traffic from the network to the NDR system to be analyzed. And that way it is also a network function. So three segments or three principles in the zero trust networking is that minimize lateral movement. That is your blast radius. So if you have an attack, you will always have an impact. What happens if somebody gets access to your network? And someone's poor laptop is a victim and somebody gets access to that. If the lateral movement from there means that the attacker can move within the network anywhere they wish if they find another weak point. That is what they always try to do. That's why it is important to minimize the lateral movement, that the movement within the network is extremely limited. Trust nothing. Only allow traffic between the microperimeters, those segments, only explicitly allowed. So allow only what is absolutely needed and explicitly deny everything else. So that way you basically only allow that traffic that has been pre-approved and you know that we need this application or protocol, and always verify. It means that when you have this explicit deny in a network, when you have new, let's say, legal traffic, you need to validate it first. Is this good? And maybe it's a new application and you want to validate what does it do. But when you know, then you can approve it. And what about if that is a bad traffic? Then you catch it. So that is what we always recommend to do within zero trust networking. So let's start first is the access control. In campus networks, of course, you have the access control requirement that you need to know who is trying to log into the network, who is that user, who is the device, a company device, if that is somebody else's device but using correct credentials. Um, this means that the first of all, it is typical when you join a Wi-Fi network, it uses a password or certificate authentication for the end user's device, and so forth. Same on the wired connections for the switching infrastructure. Uh, Typically, this is a radius communication with the NAC, network access control. Typically, if customer already has one of these NAC solutions, they are on-premise installed. They use LDAP protocol with the AD that you have locally in your network. And since most of the customers are already using Microsoft Office 365 and all the endpoint management and other software are cloud-based, this can be deployed in a cloud as a service. So Agni Arista Guardian for Network is available both cloud-based solutions as in this picture, and also as an on-prem version. So the way how we do is that we, of course, we authenticate and authorize the user to log into the network, but we also communicate with the other systems like the IDP, which is the Entra ID from Microsoft. Use OpenID Connect protocol there, and we consume information from mobile device management software like Intune and JMF. Intune is for Microsoft and JMF is for Apple devices, and of course Cortex and CrowdStrike and these type of endpoint security software that are monitoring how the users are using and what they are doing, if they have malware or whatsoever on their laptops. This information can be read by Acne via the API integration within these other systems and can be used as an enforcement to reject the join to the network or kick out from the network in case this happens. So we do a profiling and access control policies setting to the network, and we can create the identity-based microsegment for the users that are joining to the network. So how we do that, first of all, we need to understand who the user is, and we also need to understand what the device is. We also can understand where the device is and how the device or the user is actually behaving. So who the device is that we integrate with the other systems like Entra ID from Microsoft, etc., also certificates and so on. We also know what the device type is, as we get information from the network poster, but also the DHCP and LNTP and all such information. And so HTTPS is also revealing information that what the device is. So we can use, if the device is, for instance, is at the correct location and it's using the user is using a corporate issued laptop and has installed all the virus checks. These are the check marks that if these are not true, then you don't get access to the network. Everything could be right, but somehow you're magically connected to an IT manager's switch in the server room. Why? You shouldn't do that. Or somebody miscables the printer to be in a wrong port, for instance, or somebody tries to get access to the printer by using the printer port whatsoever. So all these things can be used as a selection method to allow or reject the user to join the network. And if the user starts misbehaving, the system or the EDR or CrowdStrike or something finds out that user is doing something, Agni can get in the information of that. Or at the network level, somebody does something harmful, is clearly a victim or being used as a prepare for a ransomware attack and so on. We get the information from the network devices NDR, and Acne can guarantee that user. So how does that thing work then? Access control includes, of course, the segmentation. Segmentation are the policies. So we can define different policies. We call them segments because this is micro segmentation. So here are three examples. So Wi-Fi access points, for instance, they could be authenticated as a device itself that somebody just cannot deploy whatever access point in the network. We can say that you must then go into this VLAN and there's an ACL access list that allows you only talk to radios and TCP 443 only and nothing else. Corporate iPhones is an example that you need to have certain type of certification for authenticating your device, and it must be an Apple phone. For instance, if a company has a rule that no Android phones are allowed, and the user must be in a finance group, and the phone or the device must be issued by the corporation. So it must be detected that, yeah, this is paid by the corporation, and no, bring your own devices, for instance, is not allowed. All these can be used as an example, quite hierarchical way of detecting and selecting how the device is accepted to the network, and then we can set the predefined role that is already in the Wi-Fi access points that use these corporate iPhone roles, and that could have specific settings available for these type of users. And then an IoT example, everybody knows that these IoT cameras, they are embedded Linux systems, and nobody has a proper compliance and validation of its security patches, for instance, and why let it be there in a network that it can talk to anybody if just somebody gets access to that camera and can use it as a point for lateral movement in a network. And in this case, it is the device must be in certain location, so you just can't take out the camera and plug it in somewhere else. And the device type must be a camera. It must be from these vendor OUIs, and nothing else is accepted. And then you belong to VLAN 1004, and you have an access list that limits you to communicate to your recorder unit only, nowhere else, not even to another camera, which could be in the same VLAN, for instance, which otherwise would be possible. So these type of things, as an example, that we can really have a granular control what the user or device can do. Segmentation strategy. Customers have different strategies how to implement segmentation. Segment is a VLAN, for instance, or physical cable. In the left here, you have the traditional model of having the number of VLANs. You can have an EVPN. This is dead easy to deploy with automation. You just plug in hosts there, and they are part of the certain routing domains and VLANs. Within the VLAN, you can talk to anybody in this case. So a camera in the same VLAN can talk to another camera, and but the camera cannot talk to another host in another VLAN because the traffic must go through a VRF or through a firewall, where you would have the policies implemented to that. If you have a policy that all traffic must go to a firewall, then the firewall will be a bottleneck. And if you have a high-speed network, why limit the traffic only to the capacity level of the firewall? So on the right side, we are talking about the microsegmentation policy enforcement, where the switches and switch infrastructure as a network-wide entity can control how the traffic goes through and bypass different VLANs, and even within the same VLAN. So the segmentation is using a logic of user groups. So you have different groups of users or devices, and that can be limited to host level or network-wide level or device type level. And it's very flexible. And then you can use these permit, deny, and redirect rules. Permit and deny are obvious. Redirect means that if, for instance, you allow certain traffic, which is backup traffic between a host and a server, but then anything else must be redirected to a firewall, and a firewall then can do deep inspection for the web traffic, for instance. So these type of policies can be done, and even within the same VLAN, which is typically not possible.
Marco, since we are running out of time, please wrap up in a few minutes, and then we
Yes.
have
Yes,
minutes.
I have few more slides. So microsegmentation means that you can do these groupings, and this is dynamic settings. So we can read information from AGNI, which is the network access control, but we can also read it from the VMware or other IPAM management, and also network detection and remedy. Here's an example of the traffic mapper. You need to have a visibility to your network, what happens in a network, and if somebody is if new type of traffic that you're not aware of yet can be used to help you create policies between the user groups. Then is the NDR. NDR is the AI-driven model where we can use different sensors to capture the traffic live from the network. Here we are different from anybody else because we see the real traffic. Then we know what happens in a network, and we use the AI-based machine learning models to hunt and analyze the traffic. So we use adversarial modeling language, which is adversarial is your attacker, and modeling is that all the tricks and tactics and techniques and procedures that they use, which limits the false positives in analyzing what happens in a network, and then use hunting of the actual threats with embedded AI. And the thing here is that we can detect over 3,000 protocols and applications because we see the actual packets. So this can be embedded into the network by using physical sensors, where we use the copying the traffic from the actual devices by using span ports and tap devices. But it can be deployed into the switches as well, which means that the sensor is inbuilt into Arista switch. There we can see traffic even from IoT devices as well in a cost-effective manner. So overall, continuous adjustment means that we have Agni to control and set the microperimeters. We have MSS enforcing the policies at network wide, and then we have Cloud Vision to make this automatic. And in any changes in a network, in case of any changes in a network, it can automatically adjust the policy settings in a network. And we have full visibility for illegal traffic, and also we can monitor how the legal traffic is behaving. If they start misbehaving, we can take an action. And as always, nobody does everything all and everything which is part of security. These categories that where we are not part of, we are working together. So we provide information, API integration, and so on. We don't have to be part of the endpoint security and ticketing and SIEM management systems or perimeter security, as we don't manufacture firewalls. But we work together with this, providing API integration and white papers and solutions validated between the vendors like Palo Alto and Fortinet. So that was all. Thank you. Any
Thank
questions?
you, Marco. We actually have a few questions.
Okay.
I think that those questions we covered later on during presentation, but just for the clarity, let's confirm it out loud. So the first one is Wi-Fi management only in cloud.
No, it is also on premises. So it can be cloud-based, and but there's for customers that need to have it for regulatory reasons. For instance, we have an option to have it on your own appliances at your own premises.
Okay, thank you, Marco. And the next one, I think it was for sure answered. A Cloud Vision and Agni Arista Guardian for network identity also available in non-cloud version. So I think you confirmed it during the presentation, right?
Exactly, Julia. That is true. So all the Cloud Vision software name implies that it is cloud version only. It
Okay.
actually started as on-premises first, and then it was implemented as a Cloud Vision as a service model as well, which means that in case you're running these services in the cloud, you don't have to care about the maintenance or redundancy or availability features at all, and upgrades. They are handled automatically. They also downscale and upscale according to the demand, and it's as a service. If you're using the on-prem version as what we have, both Cloud Vision, Agni, and the Wi-Fi management as an on-prem version, then of course naturally you need to maintain the devices and software on your own.
Okay, thanks, Marco. As we can hear, Arista has many interesting solutions to support our cyber resilience. It's impossible to cover everything with one presentation, so feel free to reach out to Hermitage or Arista's representatives to discuss your individual scenarios, or use opportunity to join the roadshow and meet Arista's representatives there.
Hey, my name is Markku Rantanen.